wrong with linear? So the whole chapter is on linear. So we're looking at linear regression, and we're going to wrap up those concepts of linear regression today. The one thing I asked yesterday was for you to find a ruler. Did you find a ruler? If not, please go find a ruler somewhere, or you're going to have to use your little trick of trying to measure something with the little distance of your knuckle to your finger when you bend it down. So we need to have a ruler for the activity that we're going to complete in class. So try and find one if you haven't already. Try and go grab one somewhere, hopefully in your house. Even like a measuring tape. I'm sure you have to have some type of yardstick, measuring tape, ruler, something that you can measure in inches. We're going to do an activity kind of finalizing linear regression today. So we are going to start by looking at the homework. We're going to look at the life expectancy problem so you can understand what happens when we're like jumping and skipping years in time and how that kind of translates to trying to write the meaning of the questions, the meaning of the context of the problem. So we will start there. There is a review worksheet that, again, more linear regression problems. I also have solutions posted to the review worksheet right in the assignment. So make sure that you are checking those answers. Tomorrow you will join me in Zoom. I will answer any questions that you have about linear regression, and then you will take a quiz on linear regression. It's pretty much one problem with all the different parts and questions that you'll be asked about that one problem. And then there is a small homework assignment tomorrow, and it's a calculator exploration. So you're going to kind of explore what's going on with a function called an absolute value function, which we solved in chapter 1. So now we're going to look at the graph. But there's a little bit of a calculator activity for you to do after the quiz tomorrow. And I'll remind you about that again tomorrow. That's also listed on the agenda for the week. So try and refer to that agenda, always posted at the top of each week's list of assignments. So we are going to look at the life expectancy problem. So if you can take out your homework. You had two problems. One dealt with the consumption of broccoli, which broccoli definitely is not my favorite vegetable. Does anybody really love broccoli? It's your all-time favorite vegetable, go-to veggie. No broccoli fans? Usually I get one. I think it's a pretty healthy veggie. Do you like broccoli, Ms. Carp?
I do like broccoli.
Yeah. So that first problem dealt with like the consumption of broccoli in pounds for the year. And like it's kind of weird to think about people would eat like 4.5 pounds of broccoli for a year, one person. But I guess that could happen. If you like broccoli, I'm sure having it once a week or something like that, definitely eat 4.5 pounds of broccoli. I'd prefer salad. Or like just tomatoes and cucumbers. Anyway, all right, so looking at life expectancy here. So the table here starts at 1920, and then it jumps to 1930. And it says t equals 0 represents 1920, and then since we're counting by 10 years, there's 10 years in between 1920 and 1930, we have to make sure that you're using those values in your calculator. So if I continued this list, 1950 is 30 years from 1920. That's what that number really means. And then here we would have 40, 50, 60, 1990 is 70 years from 1920. So the first thing you were asked to do was to plug this in the calculator and graph it and then get that window. The second thing you'll be asked to do after you graph it and find a window is to get an equation. Now the key thing is you must graph it first in order to find the window. So you've got to look at the graph. And then you get the window, and then we start thinking about what the equation would look like. So if we want to come up with an equation, Annabelle, did you come up with an equation for this life expectancy problem?
Yeah, I said y equals 0.31x plus 56.2.
Nice job. So hopefully you got that same thing rounding to 2 decimal places, so 0.31x and then 56.2. The y-intercept was exact. There weren't any other decimals beyond that. The r value would be 0.98, really close to being 1. So that means the data is very close to forming a line, or it's very close to being perfectly linear. And then the question 4, the y-intercept, just kind of going through so that you remember how to form all the information here. We're writing our intercepts as ordered pairs. So the y-intercept is the b value, which is 56.2. So can somebody give me number 5? What does the y-intercept mean in this situation? So kind of looking at the information you're given to start with in the table, and correlating that with the 2 numbers that we have. So we have to be able to use the data we're given. Ava, what sentence did you come up with?
Would it be in 1920 the life expectancy was 56.2 years?
Sure, that sounds great. So you're using the 0, which represents the year we started with, 1920, and then also you're talking about what that life expectancy would be. Now remember, a little reminder, 1920, it has 54.1, but remember our best fit line goes along with the average of the points. So it's not going to correlate directly with the data value because now we're trying to pick a line that's in the middle of our data value points. But still 56.2 years. Doesn't seem like that's very old. So thinking about maybe the age of your parents, the age of your grandparents, 56 really isn't very old. People live a lot longer now. The second question we have is the slope. And that slope is 0.31. And then again, we want to kind of decide or describe what it means in this situation. Thinking about life expectancy in years. So what's going on with the life expectancy and the years? Faith, are you able to come up with a sentence for number 7 about the meaning of slope?
Yeah, every 10 years, the life expectancy goes up by 0.31.
Yeah, and we actually can say every year because once you calculate slope, it's actually over 1. And I understand the confusion that it's the data we're given is jumping by 10, but the slope of the year, 0.31, if I've kind of thought about it as a fraction, it's actually just over the value of 1. So every year, the life expectancy increases by 0.31 years. So that way, over 10 years, it's really increasing by about 3 whole years. So you get like a third of a year every year added to the life expectancy as time goes on. And that's because people learn how to live differently, live better, live healthier. There's more medical knowledge that we have now than they did in 1920. So then we have the x-intercept, which we know we take the equation and set it equal to 0. And I would take the 56 to the other side, so now it's negative. And I end up getting x is equal to negative 183, 181.3. Somebody get something different about 181.3? I think I used 3 decimal places. So when we go to kind of decide what this means, when you have a negative x value, remember this is the year. So it's saying we're going backwards in time 181.3 years. But we need to correlate that with the actual year that would represent. So in number 5, we said in the year 1920. So we want to kind of start the x-intercept the same way we did with the y-intercept. So if I started in 1920 and we go backwards in time 181 years, then we should have a new year to deal with. So does anybody know what year we're talking about if we're going backwards in time? Malachi, what did you get?
1738.
Awesome. So what happened in 1738? What was the life expectancy in 1738, Malachi?
Oh.
I wrote this as an x-intercept. What's the zero
okay.
mean?
0.
Yeah.
Yeah, okay.
The life expectancy was 0 years. That's what that number technically represents. Now, I'm pretty sure that isn't true because I'm fairly certain there were people living in 1738. But that's based off of our line of regression. And you have to remember that sometimes an algebraic model or line that we create is only valid for a certain amount of time. And we know that life expectancy isn't going to be 0. So it may have been maybe 50 years instead of 56, but we're talking about the average that somebody would live. That's what life expectancy means. So you're moving backwards in time. The key thing is if it's negative, you're going back in time. And then we're trying to decide what that number represents. The last two problems here, number 10 wants us to think about the year 2000 and what the life expectancy of the child born in 2000 would be. So we have the equation that we've been using, 0.31. I know I have to plug a number in for x. And if I go up to my chart, 1990 was 70. Well, if we're talking about the year 2000, it's just 10 more years past 1990, so that would be 80. If I wanted to talk about 2020, our current year, then we would plug in 100 because it's 100 years after 1920. So into the equation, we're going to plug in an 80. And then when you take that and plug it in, if you haven't done so already, place that in your calculator. Jaden, did you get a number for number 10? A value for number 10 for about the life expectancy of a child born in the year 2000?
Yeah. Do you want me to give like the answer, right?
Yes,
Is what
please.
you want?
Yeah.
Okay. 81 years.
Yeah, perfect. So I believe the life expectancy currently, actually, it says the average is around 77 years right now. I don't know. I thought it would be higher than that, but that's what Google told me. So maybe you can find a different number. But 77 is still pretty good. Except my mother-in-law is 78, and she's still kicking, and I have a feeling she's going to be around for at least another 20 years to drive me insane. Don't tell Mr. Kane I said that, though. You can't repeat that to him when you see him in the halls in a couple of weeks. Of course, I love my mother. Just my mother-in-law drives me insane. All right, the last question we have here. According to the model, in what year was the life expectancy only 66.2 years? So I know the life expectancy. I want to figure out the year, which is x. So taking the 66.2, plugging it in for our equation. And this is kind of nice. I subtract and I get 10. That's an ugly looking 10. And then I would divide. And when we divide, Faith, what number do we get here?
Well, I got 3.19, but I think I graphed it differently.
Do you have a calculator by you?
Yeah.
How about 10 divided by 0.31?
32.3 or
Yeah.
25, 26.
Okay, so 32 point, you said 3. We'll go with 3 because that's right. All right, so Faith, if we started in the year 1920 and I add 32 years to that, 32.3 years, what year would the average life expectancy be 66.2 years?
1952.
Yeah, somewhere in the year 1952. So make sure that you're kind of finishing that answer. So we have 32.3 years, but we want to know what year does that represent. So I need to increase my original value or go ahead 32.3 years. Does anyone have questions? Hopefully that helped kind of going through that whole problem, just thinking about all the pieces of the problem, especially dealing with years and time. Okay, so I am going to pull up the activity that we're going to do. And if you want to go to Google Classroom right now and do the same thing, please do so. So I'm going to go to Google Classroom. And in Google Classroom, there is a class activity. So I'm going to click on the class activity. Everybody have this? So just a little explanation so you understand what we're doing. I'm going to set you up into breakout rooms. One breakout room is going to be with Ms. Karp and the other one is going to be with me. And if we were in class, you would all be up, walking around, talking to each other, asking each other questions. We're not in class yet, but we can still try and do this with a breakout room. So what we're going to do is we're going to record the shoe size and the length of your forearm. So your shoe size, like I wear a 6.5. That's pretty easy. However, I am a female, and if I said to a male in our student, I wear a 6.5, they would calculate that into a male size. So a 6.5 as a female is actually a 5, a shoe size of 5 in the male size. So if I wanted to go get a cute pair of black shoes and they didn't have women's black shoes that I'd like, but I saw that there was a male size 5, they would fit me because I'm a 6.5. So flipping that, if you're a male and you wear a 10 shoe size, well, if I tell that to a female in class, then that really is an 11.5 female size. So we have to make sure that whoever is taking this information down, that you correlate that information. So for myself, I need to make sure that it all is in the female version of the shoe size. The other thing that you're going to do is you're going to measure the length of your forearm, and this is a little weird. This is where you need your ruler. So your forearm pretty much goes from your elbow until that bony point on your wrist, the really like the bone that like protrudes from your wrist. So there's that little, I think it's on the left side of your wrist, depending which one the outside. We'll go with the outside of your wrist. So you're going to measure from your elbow up to that bony point of your wrist in inches, and then that would be the length of your forearm. So I'm going to break you up into 2 groups, and then we will just kind of call on students and ask for you to give us your shoe size and the length of your forearm. After you get the data, then we're going to see if we can enter it in the calculator, get the correlation coefficient, try and think about what would the equation be from the calculator. Are there questions before I break you up into the breakout rooms? Jaden.
So you said that everybody's like shoe size for me would be going into the female size. Is
Correct.
that correct?
Yes.
Okay.
So if
Thank
you
you.
ask a male in the class, you would have to add 1.5 to the size they give you so that it matches with all the female sizes.
Thank you.
You're welcome. Any other questions? have to tell you, you are my best class with asking questions. Every other class that I have, everybody's always hesitant to ask a question. And I so appreciate that so many of you ask questions, answer questions, and I just want to say thank you. Because I really appreciate, it gives me an idea as to yes, you understand, or no, you don't, but I'm glad you guys ask questions, so thank you for that. All right, we're gonna get into those breakout rooms. You'll get a little invitation from me and you can just click join. And then you can just ask the kids, like, to just kind of call out their shoe size. If you want to call upon them, you can. Did you? Yeah, you can pick 10 of them. Yeah. And a half. Yeah. Okay. So hopefully everybody has a ruler somewhere. See if you can record the length of your forearm right now. And maybe just write that at the top of your page. If you want to be the first student, you can be the #1 student in your list, or just write it at the top of the page so that you have that information down, and then you can call in other students.